Okay, guys. So we stopped yesterday just by giving these problems as an exercise. Have you tried it out? Hopefully, many of you have submitted it as well. Now, can any one of you tell me how to find out the residues of these problems? What is the residue of this function at z equals 0? What is the residue value? You people have calculated it as well. First tell me what is the residue value and then tell me how to find it. Sanjita Sri.
0, sir.
Okay. How did you get this?
Sir, first Taylor series Z minus sin Z க்கு போட்டு divide by Z பண்ண sir.
Okay. So you will have to apply the series representation of sin z and then substitute it in the given function. Then you will look for the coefficient of 1 upon z. Am I right?
Yes, sir.
Okay. Thank you then. Okay. Next. Kaviyarsi. Kaviyarsi.
Sir,
What is the residue value for this problem?
Sir, 1 minute, sir.
You said 1 minute. Okay.
Sir, minus 2 by 15.
Seems the answer is not right. Ranjani Priya. Ranjani Priya. She is not at the meet. Okay. Saubarnika.
Sir,
What is the residue value?
minus 1 by 45.
Okay. So in order to get this, what did you do?
சார் ஃபஸ்ட்டு காட் செட்டை வந்து காஸ் செட் பை சைன் செட்டாக ஸ்ப்ளிட் பண்ணிக்கிறோம் சார். அதுக்கப்புறம் அந்த கொசைன் செட்டோட அந்த சீரீஸ் எக்ஸ்பென்ஷனும் சைன் செட்டோட சீரீஸ் எக்ஸ்பென்ஷன் போடுறோங்க சார். அந்த மாதிரி போட்டு கால்குலேட் பண்ணும்போது அட் லாஸ்ட் minus 1 by 45 வருதுங்க சார்.
Okay. So first of all, you will have to express cot in terms of cosine and sine and give the respective series expansions. Your sine series will have z in all the terms. So you can take that z outside. So finally your f of z would be 1 upon z to the power 5 and Taylor series expansion of cosine z multiplied with 1 upon Taylor series expansion of, okay, we have taken z outside. So we'll have some series in z here, right? You will have to take it to the numerator. By means you will have to apply your Lorentz series expansion for this thing. You just take it to the numerator and do the simplifications and finally look for, you will have to just look for the coefficient of 1 upon z, right? Okay. Next, Karan. Karan.
So 7 by 6.
7 by 6. How did you get this?
I expanded the expansion of sin h z also for
Okay.
1 by 1 minus z square, sir.
So that is series expansions of hyperbolic sine z and 1 upon 1 minus z squared.
Z square.
So we'll have to just give the series expansion of these things and finally equate the find the coefficient of 1 upon z. That gives you the residue value. I hope this is the way in which all of you have worked it out. Whether you believe or not, this is the way in which you have worked it out. Right? Now let us move to the next problem. So you will have to use Cauchy's residue theorem to evaluate integral over C f of z dz, where C is the circle, absolute of z equals 3, and the functions are to be varied. Okay, the first function is exponential of minus z upon z squared. Okay, now let us go back and see what does Cauchy residue theorem tells us. Anyone? What does this theorem tells us? Anyone, please?
So taking a simple closed contour in a positive sense, the function f is analytic inside and on the contour except for some singular points. If it's so, then the integral value would be the sum of the residue which is given us in the equation.
Okay. So in order to evaluate these type of intervals, we'll have to find out the all possible residues. We'll have to sum it up, and finally when we multiply that quantity with 2 pi a, that is going to be the integral value. Am I right?
Yes, sir.
Is that clear to everyone? Guys, is that clear to everyone?
Yes, sir.
Everyone
sir.
means everyone in the class.
Yes, sir.
I'm not handling
Sir.
classes to only specific people. Yes?
Yes, sir.
Okay. Okay. Now, so we'll have to apply Cauchy residue theorem to evaluate this integral. How are we going to do it? Divakar, what is the first step? Divakar?
Sir,
What is the first step? Divya Vasudevan?
Sir.
What is the first step to be done? Here, the problem is to evaluate an integral. So that is to find integral over absolute of z equals 3 exponential of minus z upon z squared dz. You will have to evaluate this integral. In order to evaluate this integral, what is the first step? That is what I am asking. Kanishk,
Sir, residue first we have to find residue.
okay, we'll have to find out the residue. Residue of what?
Exponential of minus z.
So residue of exponential of minus z upon z square. We'll have to find this one. Okay, how to find out the residues?
Taylor series of Exponential of minus z, sir.
Okay, at what, okay, first of all, we'll have to identify at what point we'll have to find out the residue. Do you know the points?
No, sir.
So which means you will have to find out the singular points, right? So what are the singular points?
0.
How did you get this?
Substitute 0, the denominator parts.
Okay, so the singular points of the given function are given by z square equals 0. This tells us z equals 0. That is, just by equating the denominator part to 0, we get the singular point, right? Or the point in which the function is not defined. There is no such point except 0 in which the function is not defined. Only this is the singular point, right? We have found the singular point. Now let us find out the residue of this function at z equals 0. Okay, that is coefficient of 1 upon z in the series expansion of exponential of minus z upon z. Okay, what z squared? Sorry. So what is the series expansion of exponential of minus z? Kavipriya.
Sir,
Series expansion of exponential of minus z. Kavirsi.
sir,
What is the series expansion of exponential of minus z? It is nothing but e power minus z. Exponential means this is e power. I am just asking for its series expansion. What is it?
sir, 1 plus z by 1 factorial minus z
Are
by,
you sure you will have plus?
so minus
Then
z by 1 factorial minus z square by 2 factorial.
minus z square. Are you right?
So z power 3 by 2 factorial.
So this is your expansion. Now you will have to find out the coefficient in the expansion of this one. So when you divide everything with z squared, you are going to get 1 upon z square minus 1 upon 1 factorial times of z plus 1 upon 2 factorial minus z upon 3 factorial, and it goes like this. So from this, if you calculate the coefficient of 1 upon z, it is going to be minus 1 upon 1 factorial, which is nothing but minus 1, right? So we have calculated till this. Now let us calculate the integral value. In order to find the integral value, f of z dz, this is nothing but 2 pi I times of sum of the residues. Here we have only one singular point, and at that singular point the residue value is minus 1. So we'll have to multiply this with minus 1. If you have more than 1 points of singularity, then you will have to find out the residues at all the singular points. Finally, add all the residue values and multiply that quantity with 2 pi I. That gives you the integral value, right? Here the integral value is minus 2 pi I. Fine. Now I will change few things in this problem that you will have to carry out now, as we did yesterday. Please don't stop thinking. You will have to think and think. That is the only thing I was repeatedly saying to you people, right? So here I am changing the function to exponential of minus z upon z to the power your roll number. So let me start with okay, from now onwards, fix if I specify R, it is your roll number. Okay, if I specify S, it is 60 minus your roll number. Okay, I'll just make use of these two notations in the problems that I modify. Right, now let me start with Abhinaya.
Sir,
What is your problem, Pa?
exponential of minus z by z.
So your problem is exponential of minus z upon z. Okay, what is the integral value?
2 pi I
2 pi I multiplied with
1.
1. Yes, good. So it is simply 2 pi I. Your value is right. Now, Akash. Akash.
Sir, கேக்குதா?
Yes. Problem is my exponential of minus z upon what?
Sir, Z தான்.
Z. Your roll number is 1.
Sir, 3.
Then how come it is z to you? I am asking your problem, not Abhinaya's problem. So this is your problem. What is the integral value? You just have to calculate 2 pi I and the residue value when this happens. Tell me, what is the residue value? Everyone try your problem.
Sir, pi I z cube, z cube.
Pi I?
Z cube.
Z cube. How come? See, I have given the steps for z squared as well. You will have to replace your z squared by z cube and then see what happens. And look for the coefficient of 1 upon z. The steps are there in the slide itself.
Sir, pi I மட்டும் தான் sir.
Okay. Just tell me what is your residue value. You are giving me the final answer. Pi I. Yes.
Yes, sir.
Okay.
So,
That
1 by
is
2.
1 by 2. So if you just replace here z cube, here you will have z cube, here you will have z squared, here you will have z, here you will have 1 and it goes this way, right? So the coefficient of 1 upon z is simply 1 upon 2 factorial. And 1 upon 2 factorial is nothing but 1 upon 2, that gives you pi I. Is that clear to everyone?
Yes, sir.
Yes,
So
sir.
this is how Akash got the integral value to be pi I. Okay. Now let me do the generalization. So whatever, okay, so in this expansion you are just looking for the coefficient of 1 upon z, am I right? So this is what we are looking for, am I right?
Yes, sir.
In the generalized sense, what can be the coefficient of 1 upon z? When Abhinaya was seeking for the answer, she got 2 pi a and the residue value was 1. Okay. For Agalya, I have done it. For Akash, he got 1 upon 2, which is the third term in the expansion. Abhinaya got the first term in the expansion and Agalya got the second term in the expansion. In general, we are talking. So we should look for which term in the expansion.
Minus
General
1 power
R.
So coefficient will be
minus 1 power r minus 1 1 by r minus 1 factorial.
Minus 1 power
R minus 1. R minus
R
1.
minus 1, okay.
1 by
R
minus 1 factorial.
R minus 1 factorial. Class, did you guys understand how we get this?
Yes, sir.
Yes, sir.
Yes, sir.
Just do the comparison and of course you can very well see. Abhinaya's roll number, which is an odd number, but she got the residue value in 1. Even Akash got the residue value in positive. Okay. They both be, even though their roll number is an odd value, they got it to be a positive quantity. So alternatively, we have minus and plus, which means minus 1 comes into the scenario, comes into the scene. Okay. Whether we should get positive or negative, that has to be decided. Odd value must get a positive value, means we'll have to either add plus 1 or minus 1. Okay. In any way, we'll have to convert the odd value into an even value so that we'll get positive quantity. And when we just look at it, Abhinaya's roll number is 1, but she didn't get anything in the denominator. Okay. Even for Agalya, the same happens, but she got 1 factorial and that is 1. When Akash was trying, he get 2 factorial, that is 3 minus 1 factorial. Okay. When Anjana tries, she would get 3 factorial, that is 4 minus 1. So in this way, when we proceed, if I try, then I would get 56 factorial, that is 57 minus 1 factorial. So this is the thing. If you have worked out by your own, just substitute your R value into it and check. Okay. When you multiply your 2 pi I with this quantity, that is going to be the integral value of this function. Okay. So if you have to find out the integral value of this function, you just multiply 2 pi I with this quantity you would get. Okay. Shall we go to the next problem?
Yes, sir.
Here the problem is exponential of minus z upon z minus 1 squared. Okay. Here the singular point is 1. Okay. 1 is the only one point of singularity. Since the singular point is 1, now we will have to expand this one about 1. Okay. Not every time exponential of minus z will have the expansion 1 minus z plus z squared upon 2 factorial. That is not going to be the case always. When you expand about the origin, you get this series expansion. When you have to expand it around some other point, we'll have to do it. Okay, let us take this to be the function. Let me take this to be the function, some phi of z. Okay, then my phi prime of z is minus times of exponential of minus z, and phi double prime of z is exponential of minus z itself. So in general, my phi nth derivative at z is going to be minus exponential of minus z if n is odd, and is exponential of minus z if n is even. Okay, so we have found the derivatives, and we'll have to find out the derivative at the point 1, which means this is going to be minus 1 upon exponential of, okay, minus exponential of minus 1 if n is odd, and this is exponential of minus 1 if n is even. Okay, exponential of minus 1 means that is e to the power minus 1, that is 1 upon e. So minus 1 upon e when n is odd, and is simply 1 upon e when n is even. Now we shall write this one, that is phi of 1 plus summation n runs from 1 to infinity phi nth derivative at 1 upon n factorial multiplied with z minus 1 to the power n. So when you give exponential of minus 1, that is going to be 1 upon e minus 1 upon e multiplied with 1 upon 1 factorial z minus 1 plus 1 upon e multiplied with 1 upon 2 factorial multiplied with z minus 1 squared minus 1 upon e multiplied with 1 upon 3 factorial z minus 1 cube plus etc. It goes this way. So we can take this 1 upon e outside, so that it is simply 1 minus z minus 1 upon 1 factorial plus z minus 1 whole squared upon 2 factorial plus z minus 1 whole cube upon 3 factorial. Sorry, we have minus here, plus it goes like this. So this is the series expansion. Now let us calculate what it is. So it is 1 upon e multiplied with 1 upon z minus 1 squared multiplied with 1 minus z minus 1 upon 1 factorial plus z minus 1 squared upon 2 factorial minus z minus 1 cube upon 3 factorial, plus it goes this way. When we take this inside, 1 upon e multiplied with 1 upon z minus 1 squared minus 1 upon 1 factorial multiplied with z minus 1 plus 1 upon 2 factorial minus z minus 1 upon 3 factorial plus etc. So this goes this way. Now we'll have to find out the coefficient of 1 upon z minus 1. Since we are looking for the residue at the point z equals 1, we'll have to look for the coefficient of 1 upon z minus 1. Right? If it is about general point z naught, then we'll have to look for the coefficient of 1 upon z minus z naught. So this is what we'll have to find. Right? So this is 1 upon e, which is to be multiplied with every quantity multiplied with 1 upon 1 factorial. So that is minus 1 upon 1 factorial. So it is simply minus 1 upon e. Therefore, integral exponential of minus z upon z minus 1 squared around the curve absolute of z equals 3 is 2 pi I multiplied with minus 1 upon e, which is nothing but minus 2 pi I upon e. This is the integral value. Is that clear?
Yes, sir.
What about others?
Yes, sir.
Yes, sir.
Okay. So now if I make some changes in this, can you guys do it?
Yes, sir.
Okay. So let me modify this problem in two different ways. The first way, Usual thing, exponential of minus z upon z minus 1 to the power, yes, that is your 60 minus roll number. Okay, then only this. Okay, now let us do the first one. Second, you can take it as an exercise. Now let us start with Veerapriya. Veerapriya. She is not here. Yamini.
Sir,
Tell me your problem.
exponential of minus z by z minus 1 part 54.
So your problem is exponential of minus z upon z to the power minus 1 to the power
4, sir.
4. Good. Okay, you have your exponential of minus z. You have that with you, right? You just have to divide z to the z minus 1 to the power 4 along and tell me the residue. What is the residue value? You have the terms here, right? Instead of dividing that by 1 upon z minus 1 squared, you will have z minus 1 to the power 4.
Okay, sir.
Okay. Here you will have, here instead of this 2, you will have 4. Right?
1 by z minus 1 the power 4.
I don't want every term. You just tell me what is the coefficient of 1 upon z minus 1. That is enough to me.
Okay, sir. 1 minute.
Others, work out your problem and if possible, try to find out the generalization in which everyone can get the answer.
One, sir.
No, it is not 1. I am asking for the coefficient of 1 upon z minus 1. You must have z minus 1 in the denominator. And what is the constant that is associated with that?
Sir.
Yes.
Minus 1 by e power e 3 factorial.
Minus 1 upon e multiplied with 3 factorial. Yes, good. Okay, can you guys do the generalization?
Minus 1, the whole power s minus 1 divided by e into s minus 1 factorial.
And this quantity is to be multiplied with 2 pi a in order to get the integral value. Yes, good. So it is quite similar to that of the previous problem that we have seen, right? Okay, now let us move to the next problem. That is z squared exponential of 1 upon z. What is the point of singularity here? Once you know the point of singularity, then it is done. So if we have function in the quotient form, we equate the denominator to 0 to find out the singular points. Here it is not so. But still this function has a singularity and the residue can be found. Can you identify the point of singularity? So the singular point means in which the function, by definition, it is the point at which the function fails to be analytic. Okay, analyticity may not be possible at a particular point if the function is not differentiable at that point, if the function is not continuous at that point, even if the function is not defined at that point, then the function cannot be analytic at those points. Okay, you will have to look for these many possibilities. Can you identify some point in which the function is not itself defined? Here that has to be used. Shruti?
Sir,
Can you identify some point in which the function is not even defined?
z is equal to 0.
Yes, good. So this one we have seen in the very first unit itself. I don't know why you people are thinking this much. The singular point is z equals 0. So you can give the exponential of z, which is nothing but 1 plus z squared upon 2 factorial plus z cube upon 3 factorial plus etc. From this you can write down what is exponential of 1 upon z. This is nothing but 1 plus 1 upon z plus 1 upon z squared into 2 factorial plus 1 upon z cube into 3 factorial plus etc. So now you will have to multiply just z squared with this. So when you do so, you get z squared plus z plus 1 upon 2 factorial plus 1 upon z times of 3 factorial plus etc. Now the coefficient of 1 upon z is 1 upon 3 factorial, which is 1 upon 6. Therefore, integral over z equals 3 z squared exponential of 1 upon z dz is nothing but 2 pi I multiplied with 1 upon 6, which is nothing but pi I upon 3. Is that clear?
Yes, sir.
Yes, sir.
Okay. The next problem is your function is given to be z plus 1 upon z squared minus 2z. What are the singular points? Guys, what are the singular points?
Z is equal to 0, Z is equal to 2.
Z is equal to 2 and Z is equal to 0.
1, 0, sir.
2 and 0. Right? So which means you will have to find out the series representation about z equals 0 as well as z equals 2. These two representations we must get. Okay, when we try to get the representation about z equals 0, the numerator we have as it is, and the denominator we take z outside, then we have z minus 2. Right? Here we'll have to do some modification. Right? Your z plus 1 upon z, let that be there as it is. Okay, we take minus 1 upon 2 outside. So it becomes 1 upon 1 minus z upon 2. Am I right? Guys, is that clear?
Yes, sir.
Okay. Then we have the z plus 1 upon z and this minus 1 upon 2. And when you give the series expansion to this, you are going to get 1 plus z upon 2 plus z squared upon 2 factorial plus z cube upon 3 factorial plus etc. So we have, sorry, z upon 2, z squared upon 4, z cube upon 8 plus etc. Am I right? That is z upon 2 whole or 1 whole squared whole cube. It is in the form of 1 upon 1 minus z. This is 1 plus z squared plus z cube plus etc. In the place of z, we have z upon 2. That's it. Is that clear?
Yes, sir.
Okay. Now you can divide this z everywhere inside. So it is minus z plus 1 upon 2, 1 upon z plus 1 upon 2 plus z upon 4 plus z squared upon 8 plus etc. Now we'll have to multiply these things inside. So 1 upon 2, let me have as it is. When I multiply only that z inside. Okay, term wise multiplication let me do. So it is 1 plus z upon 2 plus z squared upon 4 plus etc. And when I multiply 1, I will have only 1 upon z plus 1 upon 2 plus 1 z upon 4 plus etc. Now I will just have to collect the coefficients of 1 upon z. Right? I'll just have to collect the coefficients of 1 upon z. If we just look for it, what we have is only this term. Am I right? Only this term gives me 1 upon z. And this minus 1 upon 2 is to be multiplied with everything. So coefficient of 1 upon z is 1 upon minus 1 upon 2. This tells me residue at z equals 0 to the given function is minus 1 upon 2. We have just found only one residue. In a similar way, we'll have to find the other residue that is about z equals 2. Okay. When we try to find out the residue about z equals 2, the z plus 1, this thing is there, right? So this has to be written z minus 2. Okay. Yeah. This has to be written this way. Z minus 2 plus 3. Okay. We write this way. And z minus 2, we take it outside. And we have 1 upon z, right? So this quantity has to be written as z minus 2 plus 2. It has to be written this way. So z minus 2 plus 3 upon z minus 2. And here let me just take this 1 upon 2 outside. So it becomes 1 upon 1 plus z minus 2 upon 2. Okay. So z minus 2 upon z minus 2 means it is simply 1 plus 3 upon z minus 2. Which is to be multiplied with, we have this 1 upon 2 here. So this is to be multiplied with the series expansion of this quantity. So that is 1 minus z upon 2 upon 2, sorry, z minus 2 upon 2 plus z minus 2 whole squared upon 4 minus etc. Okay, when we just multiply these two quantities, I will have this as it is, then plus 3 upon z minus 2 minus 3 upon 2 plus 3 multiplied with z minus 2 upon 4 and then minus etc. So this is what I have. Now I'll have to find out the coefficient of 1 upon z minus 2, and that is equal to what? Simply 3 here and 2 here, that is 3 upon 2. Okay, therefore the integral value, okay, let me just write here in after this, come here, integral over absolute of z equals 3 z plus 1 upon z squared minus 2z dz, which is nothing but 2 pi I multiplied with minus 1 upon 2 plus 3 upon 2, which is nothing but 1. Therefore, the central value is equal to 2 pi I. Okay. When, okay, here I have not only worked out this problem, I have given you the ideology on how to expand things in a Lorentz series. Is that clear? Basically, is that clear?
Yes, sir.
What about others?
Yes, sir.
Guys, what about others?
Yes, sir.
Yes, sir.
Okay, if I suppose in this problem itself, if I change the region, okay, integral of the same function, but this is absolute of z equals 1 means only one point of singularity is lying inside the given contour, and that is 0. So you don't have to calculate the residue at z equals 2 because that lies outside. This integral value is going to be simply 2 pi I multiplied with minus 1 upon 2, that is going to be minus pi I, because only this point lies inside this. But both these points are lying, the 0 and 2, both these points are lying inside absolute of z equals 3. Is that clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Suppose if this is the given thing, if this is the given contour or something like this, then what happens? We do not consider this quantity, we just consider only 2. Okay, that may be the case sometimes. Okay. Okay, guys. So today you are trying out this modification, right? And in these two, I shall give you a few modifications. Z to the power R, okay, Z to the power S, exponential of 1 upon Z, okay, and this is one modification, and the second one is Z to the power R, exponential of S upon Z. This is the second modification. Okay, here just try out these 3 problems, that is enough. So that's it for today. Thank you.